In this video, we're going to look at how to graph a polynomial that is in factored form. The first thing we're going to do is figure out what the degree of the polynomial is. In this case, if we multiplied it out, the highest power would be x to the fourth, x squared times x times x. So we know that both ends are going to point up. Now, if there had been a negative coefficient in front of the entire polynomial, then both ends would have pointed down. Next, we're going to determine how many turning points or vertices there could be, the maximum number. The degree is 4, so the maximum number of terms is 3. So that means as I'm figuring out other things in the graph, if I end up with a graph that has more than 3 turns in it, I've done something wrong. The next thing I'm going to do is plot the y-intercept. So if I put 0 in for x, I end up with 0. So that's my y-intercept. Now I'm going to find all of the zeros of the function by setting each factor equal to 0. So each one of these factors set equal to 0 would make the polynomial equal to 0. So if x were 0, the whole thing would be 0. If 3 were 0, the whole thing would be 0. I'm sorry, if x were 3, not if 3 were 0. If x were negative 4, the whole thing would equal 0. So I'm going to plot those on my graph. Now notice that I have a degree 4 polynomial, but only 3 zeros. So that means one of them must be a repeated 0. So we're determining the multiplicity of zeros. Notice that since this is an x squared, that means that we could think of this as x minus 0 squared, that 0 actually occurs as a 0 twice. So the graph is only going to touch there. It's going to cross at 3 and at negative 4. So now, with the endpoint behavior being what it is, and knowing those pieces of information, I have to draw something that looks like that. It's got to cross, touch, and then touch there, and then cross there. Now here's the actual graph. We were fairly accurate. If we wanted to be more accurate on how low we had to go before turning, we would have had to find some extra points in there, but I'm okay with you doing this. One thing you should notice, though, is that I probably should have drawn this one a little bit lower. Since these points are farther apart than these two, then that means the dip is going to go down lower. The farther apart the x-intercepts are, the lower or higher the curve will go in between them. We'll actually look at how to find these maximum and minimum points when we do our brief intro to calculus in our next, in 2 units from now. Well, actually, it is our next unit. Now, if you wanted to think backwards, you could do the same thing. If you're given the zeros in degree, can you come up with a polynomial? So if you saw a graph, for example, with these 3 zeros on it, and you knew that it had endpoints going opposite directions, could you come up with the actual equation? Well, here would be one possibility. Now, I could also put any coefficient in front of here that would give the same, it would have the same zeros. It would just either change whether the graph had an upward trend or a downward trend, or how far it stretched up and down. But these would be the 3 factors that would correspond with those 3 zeros.